All right, eighth graders, today we are going to finish up those couple of pages. And as was mentioned before, well, it was written, if you read it, we will come back and finish page 50 later, okay? We are on page 52, but it's also page 5, okay? You got that? So that's what you need to have in front of you right now is page 52, but also page 5. Get your pens, pencils, whatever you're taking great notes with, ready to go. And here we go. All right, so this also says solving a system of equations. Recall what a system of equations is. I'm going to say that again here. We'll say it a few times as we go through, but it is 2 or more equations involving the same variables. So they work together because they involve the same variables. So let's read this scenario. We have one more word problem here. Gabriella and Camilla like to race each other. Gabriella can run 10 feet per second, while Camilla can run 12 feet per second. To be a good sport, Camilla gives Gabriella a 20-foot head start. Okay, I'm gonna help you with this first part. It says, write an equation to represent the distance. See that extra S in there? It's the first time I've ever noticed that, and I've used this for a couple of years. Distance. There's an extra S in there. The distance Y. Oh, they're telling me that's Y. You know what I'm gonna do right now? I'm gonna label that on the Y-axis over here. So if distance is Y, let's see, their distance is, oh, it's measured in feet. So I'm going to put this so that this graph is nice and clear. I'm going to put distance, and I'm going to put in parentheses that that is measured in feet. You always want to clarify that so that when you look at this, we don't think we're talking about 200 miles. That'd be crazy, right? No, it's 200 feet. Okay, so distance Y that each person can run in X seconds. All right, so on the X axis, it's time. And that time is being measured in seconds. Again, that's an important distinction. Is it seconds, days, years, months? We need to know. Okay, I got my graph labeled. Now, I'm gonna use 2 different colors, one for each person, so that then when I put it on a graph, that all matches up. So I'm gonna use pink for Gabriella. Gabriella, it said, Gabriella can run 10 feet per second, while Camilla can run 12 feet per second. Camilla gives Gabriella the head start. So Gabriella gets the head start. So Gabriella is going to be Y equals, when they say 10 feet per second, that's a slope, right? 10 feet per second plus the 20-foot head start. Okay, so there's Gabriella. I'm going to change to bright green for Camilla. For Camilla, she has no head start. It's just 12 feet per second. All right, now what I want you to do right now is I would like you to pause the video, graph those on this graph, and then answer this question. Go ahead, pause me, give that a try. Okay, check these graphs out. So pink for Gabriella, most of the time students have an easier time graphing this because it starts at 20 and then it goes up 10 every second, which is also what the scale does. So that makes it easy to go up. You're going up 1 over 1 as far as the boxes go, but you're actually going up 10 seconds or up 10 feet over 1 second. Up 10 over 1, up 10 over 1. So it hits every corner like that, and these lines are pretty close together. This one's a little tricky because we know we start at 0, but then how do I go up 12 over 1 when the scale goes by 10s? That gets tricky. So I didn't go up 12 over 1. I realized that I needed something that went to this scale nicely, and I know 12 times 5 is 60, so I actually went up 60 for 5 seconds. Up 60 for 5 seconds. Does that make sense? See how tricky that is so that I could hit corners and get a better line? I like to find corners. It makes my lines easier to draw. So I did 60 feet every 5 seconds because that's 12 feet per second. And I also found this point where they crossed, which helps me answer question number 3. The solution to the graphs, the solution to the system is where these 2 lines cross. I'll say that one more time. The solution to the system of equations is where these 2 lines cross. So here's the ordered pair, and it asks me, what does it represent? What does it mean? Well, the 10 is seconds because it's the X. And the Y, the 120, is the distance. So this tells me at 10 seconds, that's the only point in this race that Gabriella and Camilla will be in the same place, and they will be at 120 feet distance. Okay, so we got page 5 done. Let's find page 6. Oh, look, it's just on the back. Flip it over. Flip it over. Here's page 6. Now, we've done a lot of word problems the last couple of days to give us an idea of what a system of equations is and to see why it's useful. Now, we're going to step back from word problems a little bit and just focus on the abstract mathematics here and what's going on. And we'll focus on that for a couple days, and then, of course, we'll come back to word problems when we feel a little better about that. So, I am going to graph these two lines. Here's what it says here. Graph each system of equations to find the solution. I am looking for the one ordered pair that will work for both of these. And the way that we're going to focus on in your 8th grade year is solving by graphing. So I'm going to underline this in pink because I'm going to graph this one in pink. It's already written in y equals mx plus b. So this is m, -1, and this is b, 5. So here I go. I'm going to start at 5 on the y-axis because you always start with the b, right? We know how to graph. And then I'm going to go down 1 over 1. Remember, negative slope goes down and over. Over is always to the right. So I highly, highly recommend you draw as many corners as you can fit on that grid. And I will show you why. I'm going to graph the other equation in green. Okay, this is a separate equation. Let me just pause here and make sure you understand, though. This pink line shows me every ordered pair solution to this equation. That pink line shows me every solution to this equation. Now I'm going to draw a green line that shows me every solution to this equation. I'm going to start at -3 on the y-axis. And then this has a +1 slope, so I'm going to go up 1 over 1, 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 and then I'm going to follow it back this way just to make sure I get as many as I can find. This green line represents every ordered pair that is a solution to this equation. The solution to the entire system is supposed to be an ordered pair that works for both. Well, where's the only place on this that's an ordered pair that is pink and green? Of course, it's the point of intersection. So that ordered pair is 4, 1. These solutions are ordered pairs, so please write them as ordered pairs with parentheses around them and a comma in the middle and all that good stuff. 4, 1 is where these lines cross. Now, here is how we check the solution. I'm going to take this ordered pair and I'm going to plug it in to both of these equations, and I'm going to make sure it works for both. Here I go. 1 goes in for y, -x. Is 1 equal to -4 plus 5? Yeah, that says 1 equals 1. Check. Okay, it worked for that one, but it's not a solution to the system unless it works for both. So let's check the other one. 1 equals 4 minus 3. 1 equals 1. Check. It really, truly is a solution to the entire system because it's the one ordered pair that makes both of those equations true. Does that make sense? If not, that's okay. Let's try it again. Number 2, here I go. I'm going to graph this one in pink. I'm going to start at 1, and then I'm going to go up 3 over 1. Up 3 over 1. I'm already out of room that way, but I want to make sure I get as many corners as possible because if I don't draw my graph very well, if I only got 2 dots and then I just kind of like made a wonky line, am I going to really clearly be able to see where these 2 lines cross? No, I'm not. I have to be really careful about how I draw these lines. I'm looking for a specific point of intersection, which means I need to draw my lines really carefully. Okay, next one, here I go in green. I'm going to graph this one. I'm going to start at -1 and go up 2 over 1, up 2 over 1. See, and look at that. It seems like maybe they're not crossing. Now we got to go follow the pattern the other way. Down 2 over 1. See how important that was that I was so careful both directions on this graph? You have to draw your lines oh so carefully so that you can see where the lines cross. All right, this crosses right down here. Where's that ordered pair? It's an ordered pair. Don't forget your parentheses. This is at -2, -5. X, y, that's how we write it, right? -2, -5. And now I'm going to check my solution. Y equals 3 times x plus 1. So this says -5 equals, why did I write -6? That was a really weird thing to do. Oh, I know it, because I did the math in my head first. This is -3 times -2. My brain just already did it. So that's -6 plus 1. Sorry about that. But here's what happened here. I plugged the x in, I plugged the y in. -5 equals -6 plus 1. Yeah, that's totally true. That's a true statement. Now let's check the other one. Y equals 2 times x, I really put the x that time, minus 1. Is -5 equal to -4 minus 1? Yes, it is. The fact that it worked for both equations, so you can always check these. You can always check if you graphed things correctly, and you should. When you get an ordered pair, plug it into your two equations. If it doesn't work for either one of them, if it works for one but doesn't work for the other, no good. You didn't find the solution. You didn't graph those correctly. Okay, let's try it one more time. Here we go. I am going to graph this one in pink up here at 2. And then I'm going to go down 3 over 2. Please make sure you're drawing your slopes in the correct direction. If it's a negative slope from left to right, it should be going downward. If you draw your line the wrong direction, you're really going to mess these up. Okay, that pink line represents all of the solutions to that equation. Let's draw the other one in green. -3. Here we go. Well, that's also negative. Down 1 over 1, 2, 3, 4. It's nice when that happens. Up 1 over 4 that way, just to finish off a nice graph here. And where do these two lines cross? They cross at 4, comma, -4. And of course, one last thing, let's check those solutions. Y is -4, so -4 equals -3/2 times 4 plus 2. -3/2, divide by the bottom times by the top. Remember we've talked about that before? 2 times -3 is -6 plus 2. Yep, that equals -4. And this one, -4 equals -1/4 times 4 minus 3. Let's check that out. Is -4 equal to -1/4 times 4 is -1 minus 3? Yep, that is also true. That means we graphed them correctly and we found the correct solution. All right, there's only one more page to this booklet. We're all done with 51 and 52. Those are all filled out and can safely go in your math binder or be looked at to help you with your work, and will of course be part of our binder check. Page 54 has the last page we need for this booklet here. It's page 7. Last one, and then we'll get all these pages finished. Okay, this says, let's get ready for tomorrow. And that's because this is going to lead us into understanding something really important for a new format. We focus so much on y equals mx plus b because I would argue it's the most useful one. But oftentimes, you're not given things that way. You're not given things in that format. So it's useful to understand how to put it in that format if it's not given to you that way. So here's what I want you to do first. Okay, I don't think you need me to walk you through every single one of these. I think you can do it without me because we've solved tons of equations like this. This doesn't even have variables on both sides. It's just a basic two-step equation like what you did in 7th grade. So once again, you are going to pause me right now and you are just going to solve these top 4 equations, solve them for y. Pause me and solve those 4 equations. Ta-da! Take a look at those, see how you did. The first step that I wrote in blue is the additive inverse step, where I took the piece that's on the same side of the variable, but it's not stuck to the variable, and I turned it to 0. So look at that step in blue, double check yours. And then the second step in pink is the multiplicative inverse, where I took the value, the coefficient of y, and turned it into 1. Okay, so I did additive inverse first, turned something to 0, and then I did multiplicative inverse next, where I turned something to 1. That shouldn't be anything new. You might have made a mistake here and there and you need to fix it, and that's okay. But this process we know how to do. We've done it since 7th grade. Now check out these down here. It says solve for y in each of the following equations. Use your steps from above to help you. Okay, we definitely know how to do these. What is different about these? Oh, they have x and y in them. See that? It says solve for y. Well, how do we solve for y when there's also an x there? We're going to do exactly like what we were doing up here. So do you see on number 1 how when we were solving for y, the first thing we did was plus 8 plus 8? Well, that's going to be similar here because we are still solving for y. But instead of plus 8, guess what we're going to do? We have to do plus 8x plus 8x. Okay, here, look at what we started with on number 2. On number 2, we started with minus 3 because we were solving for y. Similar here, but instead of minus 3, we are going to go minus 3x minus 3x. We have to zero out that whole term. We still have to move it. We still have to do the additive inverse. We still have to zero it out because we're trying to isolate the y, but it's going to look different now. Let's finish this first step on the rest of them. Look here, I went minus 10. So guess what? I'm going to go minus 10x minus 10x. And here the first thing we did was minus 3, so guess what we're going to do here? Minus 3x minus 3x. Now, here is where things definitely get different, which should make mathematical sense to you. Up here, we were just adding a constant. So when we came over to this side, we were like, oh, 17 plus 8, that's just numbers being added together. So we combined it to 25. Here's where things get different down here. I can do this and zero this out for sure, but I cannot do this. I can't do 17 plus 8x. And the reason I can't do that is because they're not like terms. They cannot be combined. Don't call that 25x. That's not 25x's, that's 17 and 8x's. I can't put them together. So here's where things get different. I still have 5y on this side, but I cannot write 25 over here. In fact, I can't put those together at all. So I'm actually just gonna put them back as an expression, and I'm gonna put the x term first, and you'll see why as I move forward. I'm gonna write this as 8x plus 17, because I can't actually combine them. Okay, could I write 17 plus 8x? Absolutely, but I'm gonna put the x term first and you'll see why. Right here, I'm gonna have negative 5y over there, but again, unlike up here where it was just constants and therefore I could combine them, down here, this one doesn't have x's and this one does. Do not combine them. They don't combine. You can't combine x's with constants. That doesn't make any sense. So instead, I'm just gonna write it, negative 3x plus 12. I changed the order, but I kept the signs. See how the negative was with the 3 and the positive was with the 12? Could I write 12 minus 3x? Sure. But again, I'm going to put the x term first. Down here, now I have negative 5y. Again, those do not combine. One has an x and one does not. So I'm going to write negative 10x plus 20. And one more time here, I zeroed that out. This is now negative 1/3 y. And these do not combine. They're not like terms. So I'm just going to write negative 3x plus 6. All right. That's the additive inverse step. You can absolutely still do it if there's an x stuck to the term. You're zeroing out the x term just like we did with variables on both sides, but you're doing it for the purpose of solving for y. And when you bring it over here, it doesn't combine, unlike up here where they were just constants. Now look at the next step we did in pink. That's also the next step we're going to do down here. It certainly gets trickier though. Of course it does, because now we have many terms. And the nature of division is, if I go like this and say I'm going to divide by 5, well, what do I divide by 5 over here? And the answer is everything, okay? So some students like to write it out like this, where you say, I'm dividing everything by 5, and that's fine as long as you really recognize, here's what's happening. That turns to 1. This is now, and I'm just gonna leave it as a fraction, that's now 8/5 x, but this is now 17/5. So you can write a big divide bar and then show yourself, hey, wait, doesn't that look familiar now? Doesn't that look like y equals mx plus b? What you did in solving that for y is you took it from a form we're not familiar with that doesn't help us much and put it into a form that we know about, namely slope-intercept form, y equals mx plus b. Let's do that again right here. Divide by -5. Some students like to write the big bar. Some students forget to divide everything when they do that, so some students write it on every single term. And that's a good idea too, to remind yourself, I am dividing everything by 5, because that's the nature of division. I got to do it to everything. It's like when you multiply and you have to distribute to everything. Division is like that too. So now watch your signs. Watch this. -3 over -5. Watch what this turns into. +3/5 x And 12 over negative 5 is just negative 12/5. Doesn't combine, so we just leave it like that. But it's y equals mx plus b. Okay, let's finish these up with the promise that you're going to get a lot more practice on this over the next couple of days. Look, I just divided everything by negative 5 so that I could solve for y. Watch this. Negative 10 divided by negative 5 is positive 2x. 20 divided by negative 5 is negative 4. That one doesn't even have any fractions left. There it is, y equals mx plus b. Solving for y gets you y equals mx plus b. This one's a little tricky. I had to multiply by negative 3, which means I have to multiply all of this stuff, like distributive property, by negative 3. And here's what I get. Positive 9x minus 18. Okay, there's a heads up for what we're doing next. You do not have to do this yet on your Canvas quiz today. Your Canvas quiz today requires graphing, graph paper. Watch the video to help yourself get started and let your math teacher know if you have any questions.